Let's move on to establishing exact class boundaries and counting our observations. How do we decide class limits? Class limits are the starting and ending values of each interval. For example, 10 to 20. 10 is the lower class limit, 20 is the upper class limit. These limits must be clear and definite. They should not overlap. They should not leave gaps. And we must avoid confusing open-ended classes like above 50 unless absolutely necessary. Clarity ensures every observation fits into one and only one class. 5. How do we count frequencies? Frequency means the number of observations falling into each class. The chapter suggests using tally marks. Each observation is placed in its correct class. Tallies are drawn. Every fifth tally is crossed diagonally to make counting easier. This prevents mistakes when data is large. Then the chapter gives a warning. When we group raw data into classes, we lose some details. The exact individual values disappear. Instead of knowing someone scored 67 or 68, we only know the score lies in 60 to 70. To represent the entire class, we use something called the class mark, which is the midpoint of the interval. This simplification causes what we call loss of information. But the trade-off is worth it, because now raw data becomes readable, patterns become visible, comparison becomes possible. Finally, the chapter extends the idea further. For discrete variables, we use frequency arrays where individual values are listed with their frequencies. And when two variables are studied together, we construct a bivariate frequency distribution. That means we observe how two variables interact simultaneously. Let's cover frequency arrays and bivariate frequency distribution in the next part.